So, a very good evening to all the contributors from TimeChain Summer of Code 2023. And again, it's been an awesome week of completing white papers, designing wireframes, and contributing towards the development of projects at TSoC. So, well done, you guys. You all of you deserve a pat on your backs. So,
Mhm.
today we are back with another expert session with Zaved, the founder and CEO of sCRYPT, and we will be discussing all about zero knowledge proofs and deep diving into how they have become a fundamental tool in the field of blockchain. So yeah, over to you, Zaved. The stage is all yours.
Okay, thank you, Rebecca. Let me share my
Yes,
screen. It's being recorded right now, right? That's good. Okay.
correct. It's being recorded.
Mm. All right. Uh, can you guys see my screen now?
Yes, it is
Okay, great.
visible.
Yeah, thanks for the introduction. So basically, my name is Xiaohui, and I work on this project called sCRYPT. So basically, what sCRYPT is for people who have not heard about it. So it's a smart contract developer platform on specifically on Bitcoin SV. So we have a few number of products. Most most importantly, called sCRYPT. There's like a TypeScript, but a TypeScript so-called base contract thing down to we've heard about Solidity. You can think about sCRYPT is pretty much like a Solidity but running on Bitcoin. Okay, so we also offer many APIs and services to make building smart contract much easier on Bitcoin. So today, I think last time I gave a short introduction about what sCRYPT is. So today I'm going to, talk about one. I think it's kind of like a hot topic in blockchain, especially in the context of a smart contract, namely zero knowledge proof. Okay, so before I even start, I just want to get a sense, like how many people here have heard about this term before? You don't have to know anything, just heard about this term before. Zero knowledge proof. Anyone? How many people?
A
Anybody?
lot of people, 6 people to be
Okay.
approximate, they have raised their hands.
Okay, raise your hand. All right, nice. So if you don't know anything, that's fine. You know, you can also call yourself an expert because you know zero knowledge about it. All right, so today I'm going to cover, I think this is a big topic, so I'm not going to cover everything. I just want to, get you started on, what it is and how can you leverage in your blockchain apps. Okay, so it's very like math and cryptography heavy. If you really want to dive into details, at the end we have a fantastic link. So let me even jump there now. So I'm going to also put this in the show notes. So basically, we have a collection of all the things we have gathered about, regarding zero knowledge proof, including all the tutorials, videos, and different knowledge proof and how they compare with each other, and all the things you need to get yourself from zero knowledge to an expert in zero knowledge proof. So if you want to know more, I think this is the link I would recommend. Okay, so let's get started then. So what is zero knowledge proof? Okay, as the name suggests, so the idea is, you know, you want to prove something without showing the thing itself for a lot of reasons. Maybe because of privacy, because of security, or because a lot of other concerns. Okay, so you know, for me, I always want to use this example. Okay, called Finding Waldo. Okay, another raise of hand. How many people have heard about this game before? Finding Waldo. Okay, some people.
Two
Okay,
people.
okay, that's good. So for people who have not heard about this, basically you have this guy called Waldo, and then what's the challenge? So you have, a picture. It's a huge picture with a sea of objects. You have, this is just one example. It's some kind of like a ski resort, right? So you have a mountain of trees and people and all kind of objects. So for you to play this game is to finding where this guy is. Okay, so a lot of people. It's a mountain. It's a sea of people and objects. So your objective is finding this guy in the picture. Okay, so this does not itself is zero knowledge, right? Because you can just find it and then show. Let's say Alice try to find this. He found this guy. She found this guy, and then she just show where the Waldo is in this picture to Bob, and then Bob think, hey, you have found it. Okay, so that's normally how it works. But what if for Alice, for whatever reason, she wants to convince Bob, hey, I have found this guy in this picture, but I'm not giving you the exact location. Maybe for bragging rights. So, oh, I know this, but you don't know, right? Or for this maybe even for just for a lot of reasons. So for whatever, Alice doesn't want to give out the exact location. Seems impossible to do, right? How can Alice convince Bob she has found Waldo in this picture without showing Bob the exact location, right? Seems at the first glance, it's very counterintuitive, right? Because how you convince me something is true without showing me the thing itself, right? But it turns out this is very possible. Okay, so yeah, I'm not going to let you guess. I just show you one way to do it. Okay, so one way to do it is Alice prepare a gigantic board. Okay, this board, then she asks, hey Bob, can you stand in front of the board? And then she cuts the shape of Waldo in the center of the board. And then she takes the picture, and then he goes after the board, and he moves the board in the picture in a way such that Bob can see through it, and then Bob can see exactly what Waldo is in the picture. Okay, so in this way, Bob can know for sure Alice knows exactly where Waldo is, because otherwise she cannot move it in a way that Bob can see it in front of the board. But at the same time, because Bob is standing in front of the board, and he cannot see the picture behind the board, right? So he doesn't know where Waldo exact is in the picture. But at the same time, he's convinced Alice knows where it is. Does this make sense? Any questions about the scheme? Yeah, for me, I want to make this interactive. So anytime you have any question, just ask raise your hand, or put in the chat. Put it in the chat. Yeah, Rebecca, can you help me monitoring the chat if anybody is asking? Okay.
Yeah, sure. I'll speak it out loud if whenever they have a question. So Ekam is saying he didn't understand.
Okay, is anybody who understand this, who can help me explain? Rephrase it? Anybody who wants to have a try?
Yusuf.
Okay, go ahead.
So good day, everyone. So a zero knowledge proof is process that you prove that you know something without revealing the exact information. For example, you ask a question and someone will know the answer. So he knows the answer without telling the answer, without revealing the information, and he's going to prove that he knows the answer. So by using a zero knowledge proof, we can get a proof and be convinced that he knows the answer without revealing it. So that is the zero knowledge proof in brief. That's how it is. And for this game, it is a game that you find the position of someone that you don't want to reveal the position, and you want to show that you know where he is. So by using uh, zero knowledge proof, you can prove that you know the position without revealing the actual position, and you can convince someone that you know the position, and it will turns to true. So this is it in brief, was zero knowledge proof is.
How about this specific example? How is that a zero knowledge proof?
Yeah, because for example,
Finding
it is
Waldo
between
in this example.
yeah. So it is like between Alice and Bob. And maybe Alice says that you should find Waldo, and Bob will say that yes, I know the exact position of Waldo. So and Bob uh, will prove that he stole the position without revealing the actual position of Waldo. That's it. And Alice will be convinced by using zero knowledge proof.
Great.
That's
Yeah.
it in brief.
I see. Yeah. I see. Ritik or Ritak has raised a hand. Is there a question?
Yeah, hi. No, I had just like the answer for this zero knowledge proof for the Waldo thing. So basically, we are not telling where the exact position of Waldo is, rather than we are specifying where is it not, and by a series of questions, and then we are saying we are verifying the question that okay, Waldo must be present in that square box. By, if that is was I was I clear on that? What I'm trying to say.
Okay. Anyone else has a question or comments so far? Okay. Is Akam, you understand now, or you want to further clarification? Just let me know. Okay, not this game. Okay, let me try it again. So here, right, in this game, Alice make a claim. Hey, I have found Waldo in this picture. But then Bob said, hey, show me. But Alice want to do this without showing disclosing the location. So Alice bought a big board, right? And then he goes behind, and then Bob is standing in front of the board, and then Alice, cut a hole in the board center of the board, and then he placed the picture behind the board, such that Bob can see, Waldo through the hole. Okay, so in this way, Bob is convinced, right? Alice must know the location, but because he's standing in front, and then Alice the picture is behind the board, he cannot know exactly where it is. So this finish the proof in a so-called zero knowledge way, because Bob is know for sure, Alice knows has found Waldo, but he doesn't know the exact location. Make sense? Still? Okay,
Yeah,
great.
we got
Let's keep
it
going.
now.
Okay, fine. All right. So this is just one example. I think maybe another example is more intuitive if you have been into the Bitcoin and crypto space, right? So let's say Alice, wants to send some coins, right? Bitcoin. So usually how does Alice move the coins? She has some coins, Bitcoins, right? So we talk about UTXO model. So she has some coins in some UTXO that lock up to her address, right? So Bitcoin address is, you can almost think about, it's like almost like a public key, okay, right? So for people who using Bitcoin or any kind of a blockchain, usually you have a pair of keys, right? So your private key, and then has a corresponding public key. So Alice has to prove, to the blockchain, hey, I know the private key corresponding to the public key. Okay. So one way Alice can do is, Alice can just put the private key in a Bitcoin transaction, and then send it to miners. And miners, hey, is this private key the right corresponding to the public key that has this coins locking, right? That's the most straightforward way. But what's the problem here? If Alice just put the private key in the transaction and broadcasting it, is there a problem? Anyone? how does this approach work? Okay, Yusuf.
So I think Alice will put the public key, not the private key, so that Bob will produce a valid private key in order to sign the output, right?
So in this case, Alice is sending coins to Bob. So Bob's, of course, in the recipient address is going to put Bob's private key, but before he doing that, she's doing that, right? She needs to prove, hey, I know the private key to my own address. Does this make sense? There's a transaction, right? You have inputs and outputs. The output goes to Bob, but the input, Alice has to prove she knows some kind of a private key corresponding to the output she's spending.
Yes, as usual, the UTXO is like a locking and unlocking script, where the person that is sending the transaction, he is sending the output, and the person that is receiving the transaction will provide the input as the unlocking script. So that means he must provide the valid signature that is corresponding to the public key placed on top of that output, so that he can take that UTXO.
Yes. So in this case, the lock, so-called locking script, is is checking that Alice has the right private key, right? Because the address is just, you can almost think about it as a public key. So how does Alice prove he knows the corresponding private key? I mean, she can always put the private key herself in the transaction, right? But is there any downside if she does that?
Yes, by using ECDSA, electric cap digital signature algorithm. So it is a point that, yeah.
So I'm even going back. I mean, you just give out the answer, which is great. But what I'm asking is, why doesn't Alice just simply put her private key in the transaction so the miners can easily check? What's the downside of that? Yeah, somebody else already answered in the chat. So basically, if Alice does that, then her private key is exposed, right? Because everything that's sent into the blockchain is open for everybody to see, right? Which is not good, because the private key is supposed, as the name suggests, right? They're not supposed to be exposed. If Alice just give out the private key in the transaction, then everybody can see it. And then if she has any other coins, to the same address, they can just steal it, right? Which is not good. Make sense so far? That's the reason she doesn't want to to show her private key. But at the same time, without showing it, then how does she prove she knows the private key, right? You see the dilemma here, right? Again, it's like the finding Waldo again. Alice wants to prove she has the private key, but she cannot disclose the private key directly, right? Because otherwise she will, pretty much she's give up all her coins that assigned to that address. With me so far, everybody? So Alice wants to prove to the miners of the Bitcoin network she knows the private key, but she cannot just give out the private key itself. Okay. So then there's a dilemma, right? Again, that's what Yusuf just said. We use so-called digital signature scheme, right? So for digital signature scheme is, I can prove I know the private key, but I'm not showing you the private key itself. Instead, I'm showing a so-called digital signature. In this case, so-called ECDSA signature, so that everybody with my public key and the signature, they can check, hey, this can only be signed with somebody who knows the private key. Okay. Yes, Alice Alice is going to send a transaction, basically spend her own coin, and then send it to she's spending her output. The output is her own address, and then the new output is going to Bob's address. Yes, but then in the input, right, she has to prove somehow to the miners she knows the private key. So she does that through digital signature scheme. digital signature in this scheme, right, is a type of zero knowledge because she proves she knows the private key without giving out the private key, right, for obvious reasons. Okay, any questions? Raise your hand. If not, I assume everybody understands.
Yeah, no questions yet.
Okay, great. So everybody understands. Okay, let's keep going. Yeah, anytime you have questions, just raise your hand. Okay, so that's the technical part we are diving into today. So, for zero knowledge proof, right, it's a big category of cryptography and mathematics. So for blockchain, we use one type of zero knowledge proof, so-called ZK sCRYPT. Anybody who have heard about this term before, just raise your hand. You don't have to know the details, just heard about SNARK. Okay, that's good. Okay, quite a few people. Oh, okay, nice. So, okay, so for people who raise their hand, anybody wants to give a, just introduction of what SNARK is in your opinion? What is it? Anybody who wants to have a try? Just your impression. It doesn't have to be precise, or just your impression so far. Anybody who wants to share?
ZK is zero knowledge, succinct, non-augmented reality of knowledge. So
Okay,
it
great.
is type of zero knowledge proof. It used to generate the verification key and the proving key for the information to be verified and be proved on the zero knowledge proof. So, and this is one of the type of zero knowledge proof. This is non-argumentative, and there are many.
Okay, great, wonderful. So yeah, as Yusuf just mentioned, so it's one specific type of zero knowledge proof. So why do we care about this specific type? Because as the name suggests, right, the S means succinct. So in the blockchain space, we know, right, if you want to put any kind of data or computation onto the blockchain, it's quite expensive, right? So that's why we need the succinct list. So in one, meaning the proof size is small. Usually when I talk about 100 bytes or some kilobytes, right? So it's not like a gigantic, like gigabytes or even terabytes. So it's succinct. And also it's non-interactive. That means, so usually in the zero knowledge proof, right, you have two characters, right? You have two roles. One is so-called prover, one is called verifier, right? The prover wants to prove, hey, I know something to the verifier, and the verifier is going to take the proof and check whether it's good. So in this case, we use ZK because there's no interaction, because that's another so-called non-interactive, right? So interactive means the receiver can always ask the prover question that go back and forth, right? But in the blockchain space, right, because prover can just send the transaction to the blockchain, and then usually he's not online all the time, right? So it's like you sending some blockchain transaction, you send it, and then you can go offline. That's no problem. Your part is already done. So we want to make sure the verifier, which is a minor in most cases, they don't have to talk to the prover. In this case, whoever sends the blockchain transaction, because he may be already gone. He's offline. So the basically means, it's very suitable. It's a type of zero knowledge that's suitable for the blockchain use cases. Okay. So it consists of 3 steps. It's almost very similar to the digital signature scheme, right? So in the digital signature scheme, you generate key pair, then you generate a proof, and then the last you verify the proof, right? By verifying the signature. So here is also very similar. So the first step called setup. Setup, basically you generate a pair of keys, the proving key and the verifier key, okay? Then what's the input? So the input is the function. For all of the zero knowledge proof, you can think of, they are proving a function is true. So the function takes 2 types of inputs. The function you can think about is a mathematical function, right? Think about square root or cubic. It's a mathematical function. Okay. So you have two types of input. One is we're going to cover later. One is called public. So basically, both the prover and verifier know about it, and the private input, meaning only the prover knows about it. So that's what makes it zero knowledge. I'm going to cover later. So you are going to prove the prover is going to prove, hey, I know some W, the private input, that make this function returns true. Okay. So in this first case, this is the function. What's the input for the setup? Is a function you are going to prove, and also some randomness. Here you can almost think about it's like a pseudo-random list, some kind of entropy that can input here. So it's not. So this has, even given the same function, the proven key and the pair of keys, they vary each time you run some kind of random source. Okay. So we're not going to cover the details. Basically, you give the inputs as the function, and then you generate a pair of keys. Okay. So what the prover does is you get the proving key, you get the public input and the private input, and then you generate a proof. In this case, it is a very short, so-called succinct proof. Okay. So once the prover generate the proof, it's going to give it to the verifier. The verifier takes three things, right? The proving key, the proof, and the public key input. He's going to say, hey, whether this proof is valid. Basically means, in this case, oh, the prover does know some X, put together, it's going to return true. Okay. So any notable thing missing in this verifier step? Anybody notice the difference between the prover step and the verifier step? What's missing in the verifier part? Anybody notice what's missing here? It's in step 2, but not in step 3. Yes, yeah. I think a lot of people notice here. So that's make it zero knowledge, right? Because if the verifier also has access to the private input, then it's not zero knowledge, right? Because if you already know the two things, you don't need the proof. You can just plug in and then check it yourself. The amazing thing here is, the verifier doesn't know the W, but she can be, if this verifier returns accept, means the verifier is convinced the prover knows the secret W that makes the whole thing evaluate to true. Okay. So any question about the 3 steps here? The setup, the proof generation, and then verification. Yeah, for people who know about the signature scheme, that's also very similar. Okay. Any questions so far? Yeah, by the way, for people who have not noticed, so the difference between the proving key and verified key here is a pair of keys. It's very similar to the Bitcoin keys, right? You have a pair of private key and public key. In this case, the difference is that the both keys, they are public, to the verifier and to the prover, because both know these keys. That's fine. You don't have to hide it. Both of these keys are made public. Okay. So you may wonder why is this useful? Okay. So next I'm going to show a bunch of practical smart contract blockchain use cases just for you to get a sense. Hey, why do we care about the so-called ZK snark? Or this specific type of zero knowledge. Okay. So first I'm going to talk about so-called people, because of the zero knowledge, so one big part is make so-called private applications, right? Because blockchain, that's almost like a dilemma, right? So you are putting everything in a public blockchain, but then a lot of times you also want to hide information or keep some kind of information private, right? Maybe you are business, you are doing your invoicing or receipt or payment, or even yourself, right? You are publishing, you are sending payment to some certain merchants or to your friends. You don't know you don't want to put all the financial transaction public in the out, in the public domain, right? So that's one big category for using zero knowledge, specifically zk-SNARK for privacy applications. Okay, so I give two examples here. One is so-called Zcash. Okay, how many people have heard about this coin before? Zcash, just raise your hand. Just want to get a sense of how many people heard about this. Anybody? Okay, that's good. I wish some people know. That's good. So, okay, you guys are good audience. So for people who have not heard about Zcash, it's very similar to Bitcoin because there's both so-called UTXO based. So your coins is not in account, it's in some kind of a output. Okay, so the only difference between Zcash and Bitcoin is, in Bitcoin, right? If you look at the on-chain transactions, you can know, the sender's address and receiver's address, and you can know the amount, right? Hey, I'm sending from this Alice's address to Bob's address. Let's say 5 BTC Bitcoins. Okay, so for Zcash, it's the same. It's sending from some output to another output, but here's the difference. If you look at the on-chain, everything is like kind of like encrypted, right? So you cannot see the sender address, you cannot see the receiver's address, no, you can see the amount. So when you look at the on-chain, it's like gibbish. It's like random bytes when you look at the on-chain. Okay. So what is the challenge here? And anybody has a guess? If everything is encrypted, what may be an issue here? Anyone? What is the issue if I encrypted everything? Sender, receiver, and then amount. Okay, regulatory. Okay, that's one thing. What else? Anybody has a guess? So what's stopping, let's say, Alice sending coins she does not have? Maybe she has 5 coins only, but then she sends 50. Because everything is encrypted, how do you know, as how many coins Alice have, right? Does this make sense? You cannot verify. The miners cannot see, right? Because the miners cannot see, they can know whether she's double spending or whether she's creating coins out of thin air, right? That's a challenge. Agree? Right? Because everything is encrypted, kind of encrypted, right? But then how do you verify all the transactions that follow the rules? How do you validate? Seems also contradictory, right? The dilemma. One thing, you are encrypting it. The second is, hey, even it's encrypted, somehow I want to validate all the transaction rules. For example, nobody's creating, coins out of thin air. Nobody's spending the same coins twice, and also you are not spending more coin than what you owned, right? And also you are not spending coins that belong to other people, right? Because otherwise the whole system collapses. So all these are challenges, right? And thanks for the zk-SNARK or zero knowledge, right? Even it's encrypted, the miners, they can still, you can think about in the transaction, there's also a proof, right? Proof, all these things, even it's private, hidden, but the miners can still check it. Okay. So that sounds like a magic, right? Because the miners usually when I cannot see, I cannot validate. But thanks to zero knowledge, even it's all encrypted, and the miners can still check all that follow. Okay. Yes, you have the signatures, but the signature in this case is for something that's you can think about as encrypted or hashed or something. It's not open, but still the amazing thing is zero knowledge enables you, even you cannot see it itself, the plain text, you can still verify it is correct. Okay. Any questions? Zcash? Okay, yeah, I just want to know the high level. I think for the details, if you really want to understand, dive into it. And any question?
How it is different from Ethereum?
Oh, Ethereum, everything is also public in the domain. You know who's the sender address, you know the public address. If I talk about just sending ethers around, right? You know where it's come from, you know where it goes to, and you know how many ethers is being transferred, right? But in the Zcash case, if you look at the blockchain, everything you can think about is encrypted. You cannot see anything. So it's more so-called private, which I call it anonymous. Okay. Any other question?
All right.
Okay, great. So if not, let's move to the next so-called, this is the, glad you brought up Ethereum. So this is the famous app on Ethereum called the Tornado Cash. Tornado Cash, for people who have not heard about it, is the so-called, coin mixer. So the example is, let's say we have, I don't know, like 20-ish people here. So each one of us has $1. Okay. So then we are in the same room. So we put a box in the middle of the room and everybody deposit $1, their own $1 into the box. Okay. And then later on, somebody, let's say Rebecca is going to the box and she's, she turn upside down, turn up, just swings it, just, mix all the coin, mix all the dollars. And then everybody in turn go there and pick up $1 randomly out of the box. Okay. So in this case, what's the supposed benefit? Then everybody's coin, right? Everybody's dollar may not be the dollar he deposited, right? Because now it's mixed, right? So for in the crypto space, that pretty much it breaks or make it tracing much harder, so-called increasing privacy. Okay. So then the challenges here is how do you make sure, or how do you mix it using some cryptography, right? Because if you just put one ether in and you at the same later on you withdraw another ether, people are going to link these two transactions, right? So it's like you can, but and also at the same time, how do you know somebody has already withdrawn $1, right? You don't want to people to circle double spending, right? If I only put $1, I can only withdraw $1, right? You don't want me to withdraw multiple times, which is not good too, right? So in this case, so basically the smart contract, right, using zero knowledge can validate, can enforce all these rules. For example, you cannot, if you can only withdraw if you already deposited one ether, and also you cannot withdraw multiple times. And at the same time, you're making sure the withdrawal and the deposit, they are not linked together. Okay. So it's a good way to implement a mixer. Okay. And at the same time, you're keeping it private, right? Because you don't know who deposited this and who withdrew. Okay. Any questions about this Tornado Cash? Okay, let's get to more important, I think a more interesting use cases here, which I hope some of you implement it here. Okay. So, if you look at our website, we have some great examples to play games entirely on the blockchain, fully on the blockchain. Okay. For example, you can play chess or tic-tac-toe. This ones are easy because, when you play chess, every move of your opponent and same for your opponent and vice versa, right? You know all the moves, every position of all the different pieces, okay? But what if you want to play, let's say, poker? Can anybody think about what's the challenge if you want to implement poker fully on chain? Is that an issue? Not chess, but poker. Okay, go ahead, Yusuf.
Yes, because any move is a transaction and your opponent can know your move and where you are heading to. So that means there will not be privacy because all the transactions are transparent. So he can know your move. That means the game will not be as designed.
Yes. So basically, here's the dilemma, right? First of all, you want to use the blockchain to enforce all the gaming rules are followed, right? So that means you have to put all your actions onto the blockchain. But then at the same time, in this case, right, in the poker case, you don't want to show all your hands, your cards, right, or whatever is under the deck to your opponent, right? Because then that's not good, right? That seems the dilemma here, right? So that's a very good use case for so-called, ZK Snark. In this case, I call it incomplete information games. So a lot of games, right? So for example, Dark Forest, I put as a Battleship, World of Warcraft, right? For any kind of big multiplayer, massive online strategic game, usually it's complete, so-called a hidden information game, right? So if I'm like a player, let's say World of Warcraft, I'm in this region, I can only see my neighborhood, right? I don't know what's going on the other side of the room or on the other side of the world. I don't know where it is, right? So that's the problem, right? For all kinds of these games. So, intuitively you think, oh, maybe this is impossible to do fully on chain, right? Because let's say I play poker or Battleship, right? So another raise of hand, how many people have heard about this game, Battleship? Battleship? Anyone? Have heard about it? Or played it? Okay, that's good. And then one. Okay, and you want to have a try? Okay. Rebecca, just say what this game is.
I didn't know it was
Battleship.
a game. I thought you were referring to the movie. I have seen the movie wherein they do all that coordinates, like they predict the next move of the monstrous ship, and the army navy ship is able to target that anti-hero ship. Some of that.
Yes, yes, yes. So for people who have not played with it, so you have it's a two-player game. So basically, as this picture shows, you have each have their own fleet, right? Alice and Bob has their own fleet. So this game is done in two steps. First, each of the player has to place all her fleet onto the board, and after that, she cannot move. She cannot move the fleet, and then the game starts. The second phase. So each one takes a turn to guess where the enemy's fleet, opponent's fleet is, and then there is so-called fire at some coordinate. Let's say, oh, Alice says, hey, I want to fire at C7. Is it a hit or is it a miss? And then Bob has to answer faithfully. Okay. And then whoever sinks the opponent's entire fleet first wins, right? So simple game. But then the challenge, if you want to do a blockchain, right? You put all the fleet location into the blockchain, then it's a huge problem, right? Again, it's like the poker analogy, right? You are giving out the secret, and then you cannot play the real game, right? Because if you know the opponent's fleet location, then you can just fire it every time. You are sure you can hit your enemy's fleet, right? The whole game is based on the secrecy, right? Because there's a board here that's blocking the view, so you don't know. You can only guess. You can only guess your opponent's fleet location, right? So that's pretty much defeats the whole purpose of the Battleship. So thankfully, we have ZK Snark, so we can simulate this game, play this game entirely on blockchain. So basically, you are committing. First, you place your location, but then instead of putting the location directly, you hash it. You use a hash function to hash the locations, and then only put the hash onto the blockchain. But then later on, you're going to generate zero-knowledge proof that, hey, if this is C7, is a hit or a miss. You are going to generate proof, and then the opponent having the proof is going to be convinced, hey, you are not cheating. If it's a hit, you cannot cheat. Okay, so you can use the zero knowledge to prove that. So basically, we also have a course. You can go to our website, sCRYPT.io. There's even a full example. Go to our academy. There's a full course telling you. I'm also going to put it in the show notes. So basically, you can go to our website, and then we have a full course about the battleship. How do you, from zero to you become a hero? You can know exactly how to build this game and play it on top of Bitcoin. Okay. So I'm also putting in the show notes, and I put the link here too. So you can go through this tutorial, then you can build a fully functional web-based battleship. It runs entirely on blockchain. Okay, sounds cool. Any questions so far? Yeah, I really look forward to some people build some kind of games, your favorite hidden information game, and then run it on blockchain. Right? It has a lot of benefits, right? First, it's transparent. Nobody can cheat, right? And it's not, and also it's like poker. You can be sure this game is provably fair. Nobody's cheating. It's not like any other kind of online casino. You are making sure cheating. There's no house. Okay. Yeah, somebody please. Yeah. If you have some kind of your favorite hidden information game, build it up. Okay. Similarly, so it's a blockchain, actually zero-K stack-powered app, originally developed for Ethereum, but later on has been migrated to a lot of other blockchains called Dark Forest. So it's a space conquer game. Each one has their own planet, and then they're trying to build a spaceship, get the resources, set up spaceship to conquer other universe. Yeah. So again, you don't want to expose your location. You don't want to know all the information about the whole universe at the same time. So basically, you are trying to hide some information by using zk Snark. You can make sure all the rules are followed. Nobody's cheating. Okay. So yeah, definitely also check that out. It's one of the most famous zk Snark based blockchain games. Okay. So we just talked about the privacy aspect of zk Snark. So that's besides privacy, you are hiding some information. You are using so-called the first part, the zero knowledge part. There's another part called succinct, right? We briefly talked about earlier. So the most famous one using succinctly is so-called roll up. So anybody heard about this term, roll ups, in the blockchain space? Anyone? Roll up. Okay, great. Okay, that's what I'm saying. You guys know a lot about the blockchain. Okay, anybody who wants to have a try or just what's your impression of roll up? What are the roll ups? Anyone? Doesn't have to be precise. Okay. Sushan, you want to have a try?
Oh yeah, so it's the concept of kind of bringing bunch of transactions together and rolling them up and like generating a proof just for those set of transactions rather than verifying each transaction one by one to further reduce the computation by rolling them up into one and having one specific proof to verify that those transactions are valid.
Great. Yeah, great explanation. Yeah, that's what Sushan just said. So usually, right, for example, in the blockchain, right, for each contract, you can think about that different states, right? You go from one state to the next, right? So-called state transition. So how do you go from one state to the next? Is basically by processing transactions, right? Let's say you have 1,000 transactions here. So normally what you do is the miner check transaction 1, 2. After transaction 1 is going to go to another state, and then state 2, and then state 2, the process transaction 2 go to state 3, and so on and so forth, right? So this place, if there's a lot of transactions coming in a short interval, this places a very heavy processing load on the miners, right? So the idea of roll up, as the name suggests, as Sushan just mentioned, right? You kind of roll up. It's almost like compressing, right? You are doing compression. So instead of, let's say, processing 1,000 transactions sequentially, you compress all of this and then into one transaction. In this one transaction, you have a proof, right? You are using succinctly. Basically, you have one proof saying all these transactions are valid. Okay. So then you broadcast it to the miners. So miners, instead of processing 1,000 transactions, they only process one transaction, right? Now, in this way. And because it's succinct, meaning it's much easier to verify the proof than generate all the proof here and processing all the transactions here. So it's much easier. So in this way, you are so-called, in a way, you are scaling the blockchain capacity. Okay, make sense? Any questions? Okay. Yeah, also we have an article about this, so I'm also going to put in the show notes. And if you want to know about more about details, yeah, it's called 09 powered rollups. Okay, so short start, you are rolling up, you are compressing 1,000 or even 1 million transaction into a single transaction. This transaction has 109 proof. Hey, all of these are valid transactions. So you are compressing, you are batching all this transaction into a single one. So in this case, you are increasing the capacity. You are scaling the blockchain. Okay. All right. So, I think here I'm not going to jump in all the detail, but this is the tool. This is one of the tools, because here, right? So I talk about, how do you do the, in a few slides back. It's coming back a little bit. We have all this theoretical result, right? So how you set up a general proof and then how you verify the proof. But then everything we talk about is theoretical, right? So this is one of the tools, so-called sCRYPT. Is a play where zero knowledge with sCRYPT. So basically, this is a tool that can let you to generate the proof and also verify the proof. So this is one that's, for example, you want to prove, here, I'm going to put the nodes. You can play with it yourself. I think Rebecca also already showed the article yesterday, right? About how do you do your first zero-knowledge proof on Bitcoin. It's using this tool called sCRYPT. So it's a software tool to help you to implement the theoretical ZK stack we talked about before. So in this simple example, you are proving, hey, two numbers, P and Q, prime numbers, that when multiplied together equals this given number n. Okay, so a lot of times you probably heard about in cryptography or even in Bitcoin, you are depending on this assumption that it's very hard to figure out. If I give you a big number, it's very difficult to figure out if you have two numbers multiplied together that give the result. Okay, so here this is just proving, hey, I know two numbers multiplied together give you this result n, and these two are secret. Okay, so it's like a Python-ish way to encode this. So this is your so-called the function you are going to prove. Okay, so once you have that, you can have setup, you can generate proof, and then you can verify. So basically, this is the way how you really use zero-knowledge proof in your smart contract and in your so-called decentralized apps. Okay, so this is the example I strongly recommend you. If you want to play with it, go through this example, and then that should give you a very good sense of, in practice, how does one leverage zero-knowledge proof in your smart contract and also in your D app. So also walk through the ZK Snark based battleship example I just shared. And for everything else, I strongly recommend you to go to this link. So basically, this is a GitHub repo we maintain that have everything from the most basic to the most advanced zero-knowledge proof links, tutorials, videos, explainers, or code samples you can use. Okay, so that's the end of the so-called zero-knowledge proof session here. And any questions? Other questions?
Yeah.
Now it's time to ask.
Can I ask,
Go ahead.
what's your opinion about AWS? Ethereum runs on AWS. What's your opinion on that?
Can you repeat? I'm not getting. Can you
What's
speak
your
louder?
opinion? What's your opinion about Ethereum runs on AWS?
Ethereum running on AWS.
Yeah,
I mean, okay. I assume this is not related to zero nines, or right?
I'm asking a general point of view.
Okay, that's fine. Yeah, I mean, it's a node software, right? You can run it anywhere. You can run it on your local computer, but if not, you can run it on AWS or Azure or Google Cloud, whatever your favorite choice is. So it's not a problem to me. I think that some people think it is a concern because it may lead to so-called centralization, because if everybody's running the node on AWS, it's pretty much the whole blockchain is controlled by Amazon, right? So for that, yeah, it's up to them. It's always a cost benefit analysis, right? If you if you want to run your own node and your computer can afford it, do it. If not, yeah, I think it's fine to run it on the cloud too. But for me, I think in Bitcoin, the good thing is you don't have to run your own node. For all of our use cases or our code, to use sCRYPT and Bitcoin smart contract, you don't run your own node. But for Ethereum, yeah, I think it's fine if you want to run on the cloud, not in a local machine.
Will decentralization comes around other domains?
Come with what?
I'm asking, will decentralization revolves around the world in other domains like healthcare, something like that? Decentralization around the globe.
Decentralization, right? You're asking.
I'm asking 100% decentralization will happen or not?
That depends again, right? What do you mean by decentralization?
Something
Everybody
like,
runs their own node?
yeah, there is no centralized server in the network.
Yeah, in the Bitcoin miner network, you don't have a centralized server, right? Because every miner runs their own node. But the users, they don't have to, right? It's like, hey, I'm running. It's like we're now using, Google Meeting, right? I'm guessing you are not running the Google Meeting server, right? It all depends on use cases. So if we just want to have the remote, video meeting, it's one way. I mean, we can just use some centralized service like Zoom or Google Meeting. That's fine, right? Because that works for us. But then it all depends on what do you mean, or why do you even need decentralization, and what do you mean by decentralization? So in the network space, decentralization means, what you just mentioned, it's mostly meaning like a peer-to-peer. And there's no server, centralized server. Everybody has to go through like a meeting we're having right now. It's almost like for people who's old enough who may heard about the BitTorrent or some kind of like P2P sharing, or in the blockchain space, right? The mining network is peer-to-peer. But that doesn't mean all the miners have to run the node. Right? You only have to run the node if you're mining. Otherwise, you can use some other kind of a so-called client, thin client. You don't have to run the own node yourself. So in that case, in this sense, you're never going to have 100%, because that just doesn't make sense for everybody run the Bitcoin node. Then why do you even run it if you're not mining? Okay, that's just my opinion. Okay. Any other question?
May I know what are the projects you are working right now, other than sCRYPT?
Oh, for me, it's just 100%, 24/7, 365 days a year, days a year on sCRYPT, because it's my project. So it's a huge project. It's basically it's a foundation for all the smart contract on Bitcoin. So not only we have the TypeScript-based smart contract language, but also we're now adding all the services. So we're becoming a full stack integrated platform as well. Also, we also have all the education materials, and yeah, it's a lot on the plate. That's one. I'm not working on anything else at the moment. Okay, Akram is saying something called Charm Peterson ZK nonce proof. I've not heard about that specific type, but Charm and Peterson is also very part. Yeah, for example, Peterson. If you check out the repo, probably have some Peterson, so-called Peterson commitment. So it's basically another type of hashing. That's been so-called ZK friendly. Basically, it's easy to generate proof than so-called other type of hashing like SHA-256 or SHA-1 or even MD5. So I don't know the specific detail, but yeah, maybe you can put more links in the comments of the show afterwards if you find more information, or I'll submit a PR to this repo so more people can know about this. Okay.
Yeah. All right.
Mm-hmm. Any other question?
Well, script supports in MetaMask or somewhere like SolveWorks.
So right now we have a few wallets that support us. Most notably, sCRYPT, Dot Wallet, and Tau. Tau is the one who's in the Bitcoin S3. They also have a wallet. So sCRYPT, you can think about it pretty much like a MetaMask but for sCRYPT. So for MetaMask, I'm not sure. It all depends on the wallet. It's not for us. If they want to support us, then we can be supported. It's basically it's not my decision. I wish they can support us. Yeah, but for now you don't. If you install sCRYPT, it's pretty much the same. It's pretty much MetaMask but for Bitcoin. Yeah, sCRYPT. If you have not installed it yet. Okay.
Can you repeat again? Wallets supports sCRYPT once again.
Yeah, sCRYPT, Dot Wallet, and yeah, everything. Let me show you another link. It's another. So everything about us, you can also find out at let's see, wallets. Okay. So I'm also putting in the show notes too. Yeah, these are the few wallets we have done so far. So basically, you don't need MetaMask. You have our own. We have our own wallet. It pretty much works very similar to MetaMask. Okay. Any other question?
Is there any extension available in Brave browser?
Any what?
I'm asking any extension available for this wallet.
Any what on this wallet?
Extension.
Extension. Oh, what do you mean by extension?
Like browser extension. Am I right?
Oh yeah, sCRYPT is the browser plugin on Chrome. Yes, and Dot Wallet it also supports. It's a web wallet, but it's also a mobile wallet. For the web wallet, you can support us through so-called OAuth protocol. You can also use that for your app too. By extension, I mean you mean plugin, right?
Yeah.
Chrome plugin. Okay. Yes, essentially is a Chrome plugin. Okay.
Yeah.
Okay. I guess any more?
Anything else, guys? Okay, I think that's about it.
Okay,
Yeah.
great. All right, thanks for coming, everyone, and thanks for Rebecca to host it. And let me know once you have you're going to upload it to YouTube or somewhere. Send me the link. Yeah.
Yes, we will upload it on YouTube. Correct.
Okay. All right. Thank you, guys, and Have a great evening, great day, wherever you are. Okay. Bye bye.